Hello, hello. This is our last lecture, our last bonus lecture until next week we have our high challenge. As always, we have our attendance form for one student. You got it. Let's go. How's your Thanksgiving been? Good?
Better.
I did not know that we only have one more week of school. I thought we had like two, and I came back and was looking at my calendar. I was like, wait, school's done? Why do we have Thanksgiving break like this? It's kind of whack. So, just some announcements. The hack challenge submissions, the midpoints were due yesterday, and the final submissions are due the 2nd of December. So, if you have any questions, please reach out to your mentors or just ask on Ed. We will be there to answer. So, today we will be going over the FVVM model. This is a standard model that is used within Kotlin, not Kotlin, but this is the standard model that is used with I'm actually playing Jetpack Compose. This is the model, and what we're trying to do here is have 3 different components. Here you see the view model, and model. And in essence, what this is a separation of concerns. In other words, we're trying to modularize every single component so that they can each be run independently, tested independently, and allow some more abstraction and more modularity within our code. Kind of decoupling, if you've heard of this term in 2110. So let's go over some, what does this stand for? Well, it's the model view model. And what are each one of these components? What do they actually do? Well, the model corresponds with the app's data, backend logic, right? So in essence, what is the model? Well, it contains the models for your actual app. So for example, it contains all the data of, say for example, we're on Facebook, it contains the models of a user. Here it contains all the data and then what to actually do with all this data. The view model is the code-based model of what the user will actually see. So in essence, this is more of a, hey, I think I want my components to go here with this type of data, but I don't actually want to create the view yet for that, or what they actually see. And then the view is what the user actually sees. And this is ultimately constructed based off of the view model. So overall, what this does is create an extremely robust app architecture that works on very large-scale apps. And we'll see this with what we have built out and what many industry standards have used to build out their apps. And one of the key reasons why this works is because it decouples many of the components and what actually happens within our front-end apps, right? It decouples the actual UI components, what everything looks like, design, and it decouples it with the actual data. How does the logic actually work? And how do we actually deal with the data and the back-end information that we're getting? So, first part, the model. Again, the model of the app is what happens behind the scenes with the data and the logic. We call it kind of the backend of the front end. An app's model component is usually made up of repositories similar to what you guys did in homework 6. The model components may consist of components that communicate with the backend. So, once again, to repeat, the model is just a place to handle your backend logic as well as contain the data for your specific app. So to once again, go over a more concrete example. Say, for example, we have a user model. What does that contain? Well, it contains variables that actually host the name, the last login, as well as, for example, the profile picture. And it contains all this data, and then it also contains like what do we actually do with this data, or how do we actually get this data from our specific bank. Next, we have the view model. What does the view model do? Well, the view model is essentially a purely code-based representation of what our screen is going to look like. So it contains all the necessary information in order to create the screen and have it at the correct state. So it does not contain any static information, aka the size of a button, the padding of the components, any of the things that actually define the UI components, but rather the variable state information. So, for example, the profile information. And so what the view model does is, in essence, it communicates with or it gets information from the model to populate what happens on a particular screen. Finally, we have the view. What does this do? Well, this is the actual UI stuff. In native Android, we would call this would be the XML and or the activity files. So similar to what we do in Jetpack, in Android Native, where we have this partitioning between the XML and the actual activity, which is the actual UI component versus the logic. We kind of have this view part which is the UI component versus the model and view model, which are more the logic components of it. So the developers actually make the UI components update based off of the information in the view model, which is a separation of concerns, making development a lot easier. And so you might remember from a week, 2 weeks ago, we talked about how you could take out the logic or the updating of the component. You can take that out and then move it up a tier. And this is why we actually use view models, because the view, when you first create it, all as a designer, for example, and as a coder, I see, hey, I want this design. I make all these components look like they're supposed to, and then I don't have to worry about whether or not these components will actually update, because I can pass that responsibility onto the view model that someone else may be working on, which allows for a lot more decoupling of the code and allows for the separation of concerns. So, putting it all together, what this ultimately does, this is generally a very, very simple idea. It is a separation of the UI and the logic, right? We aim to separate the UI, which is both the view and the view model, with the logic of our app, the model. Just some key points that I would like to point out is the view should never directly interact with the model, and it should only refer to the view model for what is to be displayed. The view model should listen for information from the model for what to display, but should never directly interact with the app logic, and the model should directly interact with app logic, logic storage, and back calls, but should never interact with the UI. So once again, it gives each component of our architecture a very distinct role to play to enable this decoupling of our code. You might see a lot of, maybe not similar structures, but you'll see there's kind of the same idea in the model view controller, if you've ever taken 2112, where there's the model, there's the view, and there's the controller for when you actually make a game, I believe, in that class, where the model contains the data, the view contains what you actually see on screen, while the controller controls what the user interacts with, and you may see other types of models such as the factory, right? Each one of these are all in essence trying to make your life easier, as well as decoupling your code so that maybe you might see it now as a hassle when you're doing your smaller level projects, when you're working on it by yourself. However, you need to imagine what happens when you scale this up to perhaps an app similar to Facebook or Amazon, where there'll be tens of thousands of users working on it, and you don't want one person's bug on one component to propagate and have this problem propagate throughout the entire app and make it crash. This is the reason why we have all of these architectures in order to separate, clearly separate each one of these, each one of these important sections of our app. So, why separate? Coding in general becomes much more simpler when you employ these type of abstractions and separations of concern. Here, we abstract the UI development process by making the view dependent on the view model only. So, what you're doing is saying, I'm going to trust that the view model is showing the right stuff and completely obeying what it says, and that is what I'm going to display. And so, once again, as someone, let's just say you're only focused on the view component of this architecture, well, you can trust that the people or the architects or coders or coding the view model will deploy the correct things in order to actually be able to properly display things on the screen. And so there is a clear separation or division of labor between you and these other coders. Finally, we're organizing our code by separating the UI from the logic, which limits the entanglement of the app flow and also in our brains. So, to give some more concrete examples of how we as app devs go about using this. So, we make this in Eatery, and so Eatery actually uses a lot of this. When I first touched the code base, I saw it, I was like, why do we have all of this? And so, for example, we have one for logic profile, one for main screen, one for the search screen, one for bottom sheet dialog. We have a lot of them. Today, we will actually get to look at the models that we use within our Eatery loop. And for the example of this specific class, we'll be looking at the login/profile, because this is probably our most robust example of us using the model view model architecture. And also because Justin actually worked on it, so he understands the most about how he structured the code to follow this architecture. So to talk about this actual example, we have the model, which is contained in the login repository, that's the file name. The view model is called the profile view model, and the view will be the login screen, which then transitions to the profile screen. Right? These are 4 different files that we'll look into in a bit. The login repository deals with the profile caching and user and password saving and loading. The profile view model is just the view model for the login screen and the profile screen. So, without further ado, we have our demo.
So for demo today, we'll pretty much just be taking a look into the Eatery codebase, just exploring it a little bit and seeing where the this MVVM architecture appears. I've been sort of debating whether or not I'm allowed to do this, but I've sort of reasoned that, I mean, all of our code is open source anyways, so anybody can just look on our GitHub repo and see everything we're working on. So I mean, it doesn't really matter that I'm going to be showing it, right? Whatever. I'm not going to ask for permission. So,
Not many people know this.
okay, so I think I'll just debug something really quickly. Let me pull up the exact file. So here we have our login repository, And if I dig around the canvas a little bit, you see our login screen, our profile screen. Those are our actual composables, our actual UI components. So that's our, in this case, that's our view. And then our view model should be somewhere in the view model folder. Profile view model, most likely this one. Yes. Okay. So here's our three components of our MVVM. Here's our model for the login repository. All of this code here, we'll sort of sift through it a little bit, is mainly going through local storage for saving and loading username and passwords, as well as communicating with backend for actually logging in and fetching the account information and whatnot. The view model is again just like a sort of view model for the actual UI components. And so if you look through this little state class, this is kind of just like a way for us to organize what the view model will look like. You can see that there are a couple different states here that you can see may actually look like enough, or all the information that we would need in order to create actually like our information, or actually display like a profile to our user. So you can see here, we have in our state, you can have a couple of different, that's actually this entire thing. You can have a couple of different options. So you can say, be either logging in, an auto logging in, it's kind of just like another version of a login, have an actual profile data, which will have your user. If you go to a user, this will have all of your information that you need to display an actual profile to a user. And so the view model, again, is pretty much just a sort of code-based representation of all the information that the UI components would actually need in order to display everything to the user that would be necessary and would have to be changed around. Since obviously, like users, from user to user on different phones, this sort of information, all this information like net IDs, usernames, accounts, and transaction histories, all of these differ from user to user. And so having a nice like central hub to have all this information is basically the purpose that view models serve. And finally, these are two particular composables that sort of feed off of the profile view model to just like to find out what they should be showing. There are a lot more that actually use this information. And if I sort of control B here to see all the usages, there are a good amount more of other composables that do use it, but these are the main two. And so these composables are basically designed in line with the state here of the view model. They sort of say, okay, everything that the view model is saying I should be showing, I'm just going to care about that only. I don't care about anything else that's happening in the app. I'm just going to basically obey this view model and use the view model to dictate everything that I should be showing and everything that I should be displaying. And so if you came to our, I think it was our second bonus lecture, you may remember something about live data and flows and states and whatnot. You'll see here that the view model operates with something called a mutable state flow. To be completely honest with you, I'm not entirely sure what a state flow is as opposed to just a state. I just saw that whoever designed this first put those in, so I decided to copy them. I honestly don't really know the big differences. But what this allows us to do, whether it's a state flow or a state, is to use Jetpack Compose recomposition to automatically sort of reformat the UI whenever anything in the state will change. So let's say, for example, my user would, I can actually pull up the emulator here, that my user would say, in this example, switch between this, the profile screen to the settings. This sort of information would be passed as a new state to this variable here. We would pass a new value to the state, indicating that, okay, my user just tapped a different button, and now anything that feeds off of the state has to recompose. And with Jetpack Compose, as you should know, everything should automatically recompose by me just changing the state value because it's live data. And so all I have to do as a designer of the view model is whenever I want to change the state, whenever I want anything in the UI to change, all I have to do is send a new value down this state, And I can automatically assume as the designer of the view model that every single UI component that behaves or will update off of this will update correctly. So again, that sort of separation of concerns, that as a view model designer, I can just assume that all the UI works and then go from there. Similarly, as a like a UI component designer, all I have to assume, or what I can assume, is that the profile view model will just show or tell me directly what I should be displaying correctly at all times. I don't have to care about any of the inner workings behind that. I can just feed off of this state right here, which is the exact same state that's being referenced here in the view model. I can feed off of this state and just assume that whatever it's telling me is correct. And as a composable or like a UI component designer, that makes our lives so much easier because we don't have to care about anything else in our app pretty much. I don't have to care about like whether things have loaded correctly in the back end, any of that complicated stuff. I can just check if my view model says that that stuff should be displayed. And that sort of, again, separation of concerns makes it so much easier to have all of these separate developers working on these features to develop them at the same time. Even if, say, some features in the view model are not fully working, we can still develop them as if, by basically assuming that they do work correctly. And so, as a developer on Eatery, this work was done on my first semester on AppDev as an Android developer. I didn't write this. Well, I wrote a little bit of it, but this is the main class that I wrote, the login repository. And so pretty much, again, this is the model component. So stepping away from the UI, this class pretty much, or I guess it's just a singleton, pretty much just dealt with loading stuff from local storage. And so I guess I can sort of demonstrate it. So obviously we don't want to have our users log in every single time they open an app. So what I worked on first semester is having a sort of auto login here. I have a nice little spinner, and in the background it'll fetch new information, and at the same time it will cache previous information, that is sort of like store or save the previous loads information, so that while it's loading, the previous information will show up here. All of that sort of logic is held in this class of 200, 300 or so lines. And something that you'll notice is that if you were to look through all of this code, you'd see that there's absolutely nothing to do with the UI here. There's no UI like workings whatsoever. There's nothing about the UI. The only sort of way for this repository to communicate with the outside world is with a state, with kind of a similar idea with the view model. It's just a state. And basically, I never make a direct call or reference to any view, any UI component, nothing. I only have this state to communicate with the outside world. And the idea behind it, and the reason that this makes development so much easier for all parties, is that I can just assume that anyone that will need this information can just feed off of this state right here. So I'll send all of my information that's like cached logins, or like a new login, or logins that I pulled, or like a username and password that I pulled out from the local storage. I can send all that just down this state and just say, okay, anybody who needs this information, just read from this state right here. And that's all I need to say. And that makes developing a model so much easier, because I don't need to think about, oh, okay, so what happens when I load a state? Do I need to go into my UI components now and change anything, or do I need to update anything in my view model? Well, no, I just send it down the flow here and say, okay, other people deal with that. And as you can see, that is kind of the same idea when developing your view model. You basically just say, okay, whenever anything changes in the view model, I'm just going to say, UI components, people handle that. I'm just going to send it down as a state. You guys handle that, and well, I hope you did it correctly. And that sort of not having to worry about the other parts of the app makes developing these individual features so much easier. And okay, so before I was talking about the model sending information to other parts of the app, well, what's an example of actually like seeing that information being referenced in another part of the app? Well, there is a function here in the view model that is listening for updates from the login repository from this exact login flow. So you'll see that this is the same login flow that I was talking about earlier. And it's essentially collecting any information that is pushed down or sent down the flow in the view model. And what this specific block of code is doing is it's basically waiting for an auto login to be loaded from the local storage. So like when I enter reload, Eatery will automatically initiate like an auto login. And so this is let's see, what is it here? Oh yeah, so whenever I actually have the information pulled from the local storage, it will automatically initiate an auto login in the background. This is what this particular piece of code is doing. And this is an example of how I could pull information from my model in other parts of the app. So of course, with the separation of concerns of model, view, and view model, we're not actually like leaving them completely separate because, well, what good would a model be if it doesn't somehow actually end up in the app that users can see? And so obviously there will still be parts where you have to reference the other parts of the app, but the reason we do this and the reason that it's so useful in like from an industry standpoint and from an efficiency standpoint is that as a developer of login repository, all I have to do is, again, send stuff down this flow. And I don't have to care about, as I'm developing this, like any other part of the app and how that works. Because when I first got into the Eatery code base, this repository didn't exist, but the UI components already did. The view components, which are like login screen, profile screen, they already existed, and so did the view model, that already existed as well. And so when I was developing the login repository, it would be very difficult to say create the repository while also trying to like think about all of the different side effects that every load could also happen, or that every load could have, like all of the side effects that every single load from local storage could have. And so instead, just using this sort of abstraction makes developing far easier and simpler. I believe that's pretty much the gist of it. I guess we can also take a look at the actual like login screen. This should be able to log out. Okay, and so we'll take a little bit of another look into what exactly each part of the state is. So I guess I didn't really exactly clarify what the state object is here. The state is pretty much just, it's sort of just a way to organize the information in like a sort of bundle in the view model so that we can send it down the flow. So that instead of just sending down like, well, we have to send down one object at a time. And so obviously we have to send out a lot of information at one time. So the state is just sort of a bundling of information that we can then send down in like a big package. So there are a couple different ways that, or a couple different states that a view model and the like profile could have. You could, let's see. Yeah, okay. So you could either be logging in, you could either just be on the screen, or you could be in your profile. And so these correspond to the different states where I'm just on the screen, or if I'm logging in. Basically, if I were to press this login button, then a new state would be sent down, where it would actually be using the logging in state instead, with my actual NetID password that I typed in. And then once the actual login happens, which again it happens on our like model backend sort of part of our app, then the view model updates and sends down a profile data bundle instead. And our UI components will be handling all of those on their own. But yeah, that is pretty much the breakdown of what's happening on the profile screen. This is what I've been working on anyways on Eatery. I know the more exciting stuff is the actual Eatery part of the Eatery app. It would be sort of a disservice though, since I haven't really worked on that part. I guess it's a little weird to be talking about this part of the app that most people don't even use. I don't even, like, do either of you use Eatery right now? It's just like the regular Eatery. And do you use the profile section of Eatery? Yeah, that's what I thought. I don't really use it either.
There's a lot of features on here that I didn't know existed.
Yeah.
So you know there's a map component on Eatery.
Yeah, I also didn't know that at all. I don't think anybody uses it. It's hidden in a very dark corner. You can like search up directions to parts of campus. I don't really know how it works or even how to get to it.
There's like
I stumbled across it.
map thing, and then it can like puts you on a map where you are, and then where all the other eateries around you are.
Yeah, it's actually not a bad feature. It's just nobody knows about it. I didn't know that. But hopefully, this will sort of shed some light on the lesser seen part of Eatery, so that when this update inevitably does come out, hopefully you guys will update to the new version. Eventually, no release date. I've been legally required to not give you a release date. Because we've been saying next semester for like 3 semesters now. Yeah, not a great look. But once this does eventually come out, hopefully this will sort of shed some light on the lesser used parts of the app. And just know, well, I guess you guys don't use Android, but if you did use Android, you would know that I made this.
Why are you eating at 1:31 a.m.?
1:30? Okay, that is just not correct. 1:31 a.m. I was not even on.
12:27 a.m.
Yeah, something about the date and times that don't exactly match up. Weird, because most of them seem to be doing okay. I guess it's just, honestly, I don't think that's on our part. I'm pretty sure that's on Cornell Dining, because, I mean, Morrison seems to be doing okay. And then North Star, it's definitely not even open at 2 a.m. I don't know. I don't really know what's happening there. I'm just gonna blame it on Cornell Dining. Yeah, everything else seems okay. But yeah, that's pretty much a little bit of a quick look to the new Eatery coming out. Again, I know exact release date. If you'd like to just see some other stuff that I've been working on, I think I'm on the new branch. This is, yeah, the new branch.
What happened to the photos?
Oh yeah, totally ignore the fact that there's no photos. I think there's a problem with the backend right now that's making no photos show up. I did see photos last semester, and then this semester when I started working on it again, it just, like, there's so many problems with the backend that just exploded out of nowhere. One of them being that there are no images. And also that, where is it? Novik's Cafe, the new one in Ruth Bader Ginsburg, just completely disobeys alphabetical ordering. it's just up there, and sometimes it's like a ghost. Sometimes it'll just crash your app if you scroll by it. I'm not gonna try to pull my luck too many times, but ignoring that, I've also been working on like animations right now, so you can see little pop-in animations if you favorite stuff. Favoring is also one of my first features that I worked on Eatery, as well as these sorts of animations. Empty screens, so if I have no favorites and go to the favorites filter, you'll see that no Eatery is found. Very cool. As well as on the screen here. There's also animations on here. Let me just quickly favorite some stuff so I can show you. Okay. Go over here. Cool. Okay, and basically making animations in Jetpack Compose is super simple. For example, there's a little bit of an animation I put in here that literally took me like probably 1 line. There's a lot of libraries with Jetpack Compose that you can kind of just use to your advantage to very quickly implement animations like this. It's just like very small little things. I think there's a modifier that you can pretty much just do like dot animate content size, and it'll do this for you essentially. As long as like the composable, or whenever the composable recomposes and changes size, if you have that modifier, then the animation will automatically sort of tween between those two sides. Well, I also made pretty much the entire settings screen. All of these screens. You can also change the app icon. I mean, I think we'll have a total of like 3 users doing this. Maybe, if we're lucky. Okay. And this was probably the most headache-inducing part. I was like, nobody's gonna even do this. Whatever. I did it. The notifications, privacy, all that stuff.
Question: do you like this new design in comparison to the old Eatery?
I guess this has turned into user research.
Never used it.
Oh, you
Never
never
have.
have.
That's crazy.
Do you use Eatery, Sophie?
Yeah, I do. I think it looks a lot more sleek.
Yeah.
Okay, good to hear.
There was a lot of internal strife about how ugly Eatery looked. So, boom, redesigned the entire app. Because our older Eatery used Android native, and this one uses Jetpack.
Yeah, this sort of new Eatery, a lot of people ask us, like, why are we making a new Eatery? And it's half because, like, the old one,
It's not even bad.
yeah, it's not that bad. And so it's only in part because we felt the need of visual upgrade. It was mainly because it was just so, like, terribly coded, and just, like, the code base was just terrible spaghetti code. Because, I mean, it was mostly just a project that, like, the founding people of app dev worked on by themselves, just a small group without many, like, rules to abide by. And so working on it again, updating it, going and fixing bugs is just kind of a nightmare. So this is the new Eatery. We're trying to follow the sort of better coding practices, like, for example, the MVVM architecture, so that for like, not just for the designs, the newer design, but also future developers on app dev can also have a better time debugging and working with our code bases. But yeah, if you have any critiques about the designs, we are not undesigned, so you cannot hurt our feelings. You will not hurt our feelings. I hope that none of the designers are watching the YouTube video. We can cut this part out too.
Okay, I hate this. No.
But yeah, I think that's
Last lecture.
yeah, pretty much.
We're basically done now. You guys are
pretty
free.
much the gist of it. Yeah. This is our last of the last lectures, the last real, I guess the last lecture, not including the last real lecture, the last bonus lecture. Thank you guys for coming though. We really, really appreciate you guys coming out. We do have to put just as much time into these slides and with the preparing the demos as we do with the regular lectures, and we get like a fifth of the attendance. But we really appreciate you guys coming out. I was planning to bring these little Android figurines I got from a previous app dev member, but I forgot. I think correct me if I'm wrong, I'm pretty sure the Hack Challenge finale is mandatory, right? To attend.
So,
I think it is. I hope so. But yeah, I will. Yes, it should be mandatory. It not really make much sense if it wasn't, but hopefully it's mandatory. I'll bring the figurines in then and distribute them then. I think there's like 8 or so, and I don't think that will run out. Hopefully not. But yeah, we'll see. But I can't believe I forgot to bring them. But yeah, next week then we will handle this out. Okay, just to wrap up, yes, we still have our little final slide here, bonus homework. Not sure if any of you guys will be doing this, but just a reminder, and to anybody watching on the interwebs, bonus homework is due next coming Sunday. That's basically a Jetpack Pose assignment. If you'd either like to get some extra credit bonus points, it's pretty much the same as a regular assignment, or if you just like some experience working with Jetpack Pose. But we hope this last lecture gave you a little bit of an insight into what Jetpack Compose can do on a larger scale. Since I've shown in the demos just sort of like a ragtag use of Jetpack Compose, just throwing a bunch of composables on there without much of an organization. But yeah, I hope this final lecture showed you what Jetpack Compose can do if you organize it well and have it all planned out from the beginning to separate all of these parts of your app so that you can create a robust architecture that will work for not only developers working on it then, but for many developers that will be visiting the code base in the future. And if you guys are planning to apply to app dev in future semesters, this is a good look into the sort of stuff that you will be working with, since we are trying to migrate to these more modern app architectures, since it is just better. But yeah, thank you for coming. I think that's all we have for you today, and for, I guess, the rest of the course. I guess this is pretty much it, isn't it? But yes, thank you guys for coming.
Do you guys plan on applying?